JSteele's Precalculus, Part 2 of Section 7.1. We're dealing with simplifying trig functions using trig identities. So number 6, we have 1 plus cosine of x divided by 1 plus secant of x. We're going to try changing everything in terms of cosine of x. So changing everything to cosine of x. In the numerator, we will have 1 plus cosine of x divided by 1 plus 1 over cosine of x. And all we did here was change 1 plus secant of x to 1 plus 1 over cosine of x. So we used one of those reciprocal identities. The next thing we're going to try is we need to try to make a common denominator. So we are going to change the 1 in the denominator to cosine of x over cosine of x. So we will still have 1 over cosine of x or 1 plus cosine of x in the numerator, but the denominator we will have cosine of x over cosine of x, which is equivalent to 1, plus 1 over cosine of x. Now, that's just having a common denominator for the bottom. We made a common denominator in the denominator. Next, we will just combine our fractions in the denominator. So we will have 1 plus cosine of x in the numerator. And in the denominator, we will be left with 1 plus cosine of x divided by cosine of x. And all we did here was added fractions in the denominator. Next, we will take our denominator. Since we're dividing by a fraction, we're going to multiply by the reciprocal. So we will have 1 plus cosine of x over 1 multiplied by cosine of x divided by 1 plus cosine of x. Notice now we have a 1 plus cosine of x in the numerator and in the denominator. And all we did here was multiply by reciprocals. So now we have a 1 plus cosine of x in the numerator and in the denominator, so we are just left with cosine of x. So this is our expression in simplest terms, in simplest form. Example 7 is 1 plus cosine of x divided by sine of x plus sine of x divided by 1 plus cosine of x. Our first step is going to find a common denominator. Our common denominator will just be sine of x times 1 plus cosine of x. So this becomes, we will have 1 plus cosine of x, quantity squared, plus sine squared of x, all divided by sine of x times 1 plus cosine of x. So what we did in this step was common denominator and added numerators. So we kind of did 2 steps in one. Our next step, we're going to be FOILing out that 1 plus cosine of x squared. So now we have 1 plus 2 cosine of x plus cosine squared of x plus sine squared of x in the numerator. And in the denominator, we will still have sine of x times 1 plus cosine of x. What we did here is just take 1 plus cosine of x squared and rewrite that as 1 plus 2 cosine of x plus cosine squared of x. So now notice in the numerator how we have cosine squared of x plus sine squared of x. That is one of our Pythagorean identities. We know that cosine squared of x plus sine squared of x equals 1. So to simplifying this, we will now have 1 plus 2 cosine of x plus 1 in the numerator. And our denominator will still be the same. We will still have sine of x times 1 plus cosine of x. And all we did here was use the Pythagorean identity. That allowed us to take cosine squared of x plus sine squared of x and replace that value with 1. Now once we have that, we can combine our like terms. So now we have 2 plus 2 cosine of x, all divided by sine of x times 1 plus cosine of x. All we did here is combine like terms, so CLT. Now we can do our next step, which is factoring. Notice we have a 2. We have 2 2's in the numerator. So if we factor out a 2, we'll be left with 1 plus 1 times cosine of x, or 2 times 1 plus cosine of x. In the numerator, in the denominator, we will still have sine of x times 1 plus cosine of x. So this step just included factor greatest common factor, which was the 2, and we reduced. So then lastly, notice we have a 1 plus cosine of x in the numerator and in the denominator, so we can cross those out, and we are just left with 2 divided by sine of x, which we don't ever like having trig functions in the denominator, so we can rewrite this as 2 times cosecant of x. And this was just using the reciprocal identity to simplify. So notice the answer is never right there for you. There's some times where you need to kind of guess and check. As you complete more problems, these will become easier. There's really no right or wrong. There is a right way to do it, but the answer or the idea is never completely clear right away. So you can think of these problems as kind of like a puzzle. You never know what pieces go where until you try. So it's just more of a trial and error. So this is why it's great just working with partners. So this flipped classroom technique should work very well throughout Chapter 7.